myself, Ajal. Presentation is regarding the ADS part. First of all, we discuss about the presentation overview regarding the rental algorithm, system architecture, simulation result, and finally its validation. So first of all, in the cryptographic suits, there are 5 finalists, and one among the best one was coming by AES or Advanced Encryption Standard was known as the so-called rental algorithm developed by Vincent Bridgman and John Diamond, which is having 128 keys. And here we are going with certain type of VLSI implementation, and this was the Wall Street Journal showing how the weakness is another threat regarding the network security. And critical network security elements discussed over here includes confidentiality, identity, integrity, authorization, and availability. And coming to the rental chip over here, it was one of the 5 finalists, starting from the Serpent, Twofish, RC6, and Mars. And it was implemented over here with respect to 128 bit, and even higher versions are still available. And basic algorithm operation can be discussed with respect to these 4 factors. One is add-on key, subbyte, second one is session row, and its column. So here there is a modeling part. What actually happens here is regarding the random chip as such. Here the operation will be around 10 cycles, and finally it will be implemented with respect to VLSI algorithm. And next part is regarding a keying part. I might not discuss about it because it's a basic encryption and decryption part. And coming to the decoder or decryption part, the thing is that there will be a buffering and round transformation, and finally moving to a key scheduler. And again, with respect to the S-box analysis, you will be having a subbyte with two type of blocks. First one is the multiplicative reverse, and second one is the affine transform. Similarly, it will be reversed in the case of the second part, the inverse part. Then there is a block diagram of the entire chip that is showing out all these properties, and where the round key generation is one of the another part that is implemented over here. And like you will be having a measurement setup, and the clocking that is provided over here is a 20 MHz clock. And even the higher level, we are having a certain type of architecture, that is by using an ARM core, we are going to have an implementation, or we are going to interface over here. So this is a general ARM7 CPU core, where an LED light that can be switched over here, and the green bulb will be involved, and that can give the interfacing whether it is connected, tested, or okay. Then finally it will be moving towards the chip when we are getting loaded to the implementation part. You can see that here you can see certain FPGA blocks over here, and the version of AES, which is having 128-bit core, is interfaced to it. Finally, the testing part. Testing of the hardware implementation was done in Summit, where it was embedded or placed within an anechoic chamber. In the next anechoic chamber, it is a leaded chamber for exactly, and there are certain spoofs, and by using certain biconical antennas, you can give that application that take the value. Basically, you can give it to the next node with respect to a network analyzer part. And coming to the simulation part, even in the HDL or the hardware description language, you can go with the encryption and the decryption part. And the comparison of the spots with respect to the lookup tables are implemented with error and without error by using the hardware description language. And finally, once the implementation is over, you will go with the validation part. So the error correction with respect to a map report. So map report analysis will provide the final part. And by making a comparison between the software architecture and this VLSI implemented architecture or hardware architecture, the advantage over here is that you can see the throughput part or the encryption speed. Compared to the software part, you can see it is only in megabits, and compared to that of hardware, where the bit-touch module, it will be in giga range, that is 10⁻⁹. So that is the comparison, performance evaluation or throughput evaluation with respect to a software part and the hardware coding part. And this is the final layout. After implementation with respect to the simulation synthesis part, you will be going with the floor planning part or the layout part, where the IC chip itself will be modeled with respect to an RTL schematics. So in the RTL schematics, you can see the floor planning of the entire IC module. So in the case of our general purpose IC architecture, actually it is in nowadays we are going with the VLSI implementation. So almost 10 raised to 6 elements are to be available or included in the lookup table or the LUTs. So this is the implementation part. Since it's a bulk module, you can see the first one. Here you can see 1 to 10 parts. So this can be moved to the second one. Then it is the architecture part itself. You can see that the architecture has been scaled down or has been given into different 10 scales. So these are the different scales: 3, 4, 5, 6, 7, 8, 9, and 10. The last one. So the entire frame of the VLSI decrypted code has been implemented over here, and we are going with certain type of real-time implementation in the future part. And only thing is the issue or the drawback part regarding the power consumption. Since you have to give out the encryption to decryption part and you have to run the code for a long time. So that is the lengthier part. And yeah, the conclusion part, the VLSI implementation has been taken. And here we are going for even future part as a wireless implementation. And in the future work, what we have been implemented for the real-time analysis. Real-time analysis part, you can implement even with this lab view type of implementation. We call it as RIO. That real-time input and output chips are still available over here. By using this RIOs, you can have a implementation, or you can have the real-time tracking of the given data. So it is by using a DAT system, data acquisition part, and finally the implementation has been done for an implementation that can move out into a real time. Since in the previous case we have been done with the pre-fetching part, and finally the processing, or we call it as a pre-processing and post-processing. But here what happens is that we are going to go with a real-time implementation. So that is the added advantage over here. So these are my reference.
What's the title of the paper?
Fault detection scheme for AES or processing.
So basically, you are discussing an implementation of AES
Yeah.
in hardware. So where does the fault detection comes in?
Yeah, actually in the case of the each and every part. First one is in the case of the simulation part, and the second part is the verification and debugging part. Third part is the synthesis part. All these steps are interrelated with the fault part. So whenever there is a bug or the error or the fault so called, we can have the error the removal at each and in every step. So finally what happens is that if there is a bug at the initial level itself, what happens is that it will keep on scrolling, and the values that which are obtained or with respect to different parameters that we are using will be affected. So for that part we are going to take the error correction and detection at the individual level, even from the right from the simulation and up to the testing and implementation part of the hardware.
So what do you mean by bug? Is it a hardware bug or a software bug?
Purely hardware part.
Hardware bug.
Hardware implementation.
Hardware.
And just we are making comparison between the previous ones with respect to the software, with respect to the throughput analysis.
Okay, are there any previous hardware implementations of this algorithm? Have you gone through them?
Actually, it is available in the case of the previous versions. That is, in the case of Mars or even in DES and triple DES, these things are available. But the problem is that coming towards a new platform with 128 bits, the implementation part will be having a lot of heuristics. And we are making out the hardware part as such, and in order to moving out from the hardware alone, we are going to have certain type of interfacing of this hardware module, basically in this type of ARM processor, ARM.
Can you question the audience?
So why do you go for a AES instead of a DES?
Sure, you see, in the case of a DES, you can see that a lot of issues with respect to the security part and number of bit length. You know, in the case of DES, it is very less, pretty less compared to that of a rental algorithm. So we are going with rental algorithm because the first thing is that the NIST has been standardized with respect to different 5 algorithms. There were a lot of difficulties with respect to DES and triple DES. So that's the reason why we have gone for, the NIST has gone for a improved version of AES standard in the year 1997.
No, I am not asking you why you go for AES instead of a DUS. If you wanted to go for a hardware implementation, it would have been easier if you go for DUS and try
No.
to play the fault there instead of finding a fault with the AES system.
No, actually we are implementing it in a platform. It's a platform based architecture. So in that case the requirement
Which is platform based,
require-
AES or your this one?
the requirement is in order to build it with respect to 128 bit. Then another thing is the application based upon that is for wireless communication. In the case of wireless communication, say for example the IEEE standardization, it is used in the case of WiMAX implementation. So in the case of WiMAX implementation, their basic architecture in the physical layer, in the 7 OSI layer, in the physical layer itself, the requirement is in order to have a 128 bit platform. So if you are going with a DUS or triple DUS, what you have explained is exactly correct. That is the hardware complexity part, and required to the second part, the time complexity, that can be evaded. But requirement is in order to satisfy with a 128 bit. So that's the reason why we have gone or we have taken with the rental algorithm.
Okay, more questions? So let us congratulate Ajal earlier from here.
I am from IIM.
Hello.
IIM, KIM,
Kozhikode from hardware implementation. Now let me try to conclude.